And we'll go ahead and get started. People who are at home, the in-person students just did the introduction to unit rate activity. It's posted separately of this video. It shouldn't take too long, but if you want to go into that activity first before starting this lesson, it's a good introduction of what we're going to be doing today. And what we're going to be doing today is using something called unit rate to compare ratios. In that activity, you might not have been using those words, but that's what you were doing, is you were finding something to help you compare those two robots. So just start off, I've got this question here. It says a 10-ounce box of cereal costs $2.79. A 13-ounce box of the same cereal costs $3.99. In order to get the best deal, what item will you buy? Now it says with a partner, but there is 3 of you. What I'm thinking is, can we have one volunteer to write the math on the board, and then the other 2 can just help that person know what to write? Do we have a volunteer to write on the board? You'll do it? Thank you, Carlos. I think Denise said out there, but I'm going to say in here too, for this lesson, you are able to use that calculator. It does not appear like you brought them in, so I'm going to go grab the calculators real quick. I really want the focus today on finding ratios, though, and not division. That might help. Did you come up with a plan while I was gone? What are we going to do to figure out the best deal?
I can't think.
Well, it's not all up to you. You got 2 people helping you out.
I think you're going to divide $3.99 from 13 ounces and then $2.79 from 10 ounces to figure out which one's going to be the better deal per ounce.
Do we agree?
I don't know. I don't know much about it.
What do you think?
I'm checking.
Checking? Well, Carlos is doing the math, so can someone tell him what numbers to write?
$3.99 divided by 13.
What?
Mhm.
99?
$3.99 divided by 13.
That would go.
That will equal
0.306923.
0 what?
0.306923.
Alright. And this one?
that one is 1.29.
So I think this one's a better deal. Okay.
Will you check that division again? The
0.279.
Yeah.
How much? What is it?
0.279.
2.20?
There you
279.
go. Maybe you had one of the previous numbers. Now I'm curious, I see you're only writing it with two numbers after the decimal point, although they're giving you more numbers. Why are you doing that?
The other numbers don't matter. You know, well, my teachers told me like the main one is the both, which one is the biggest. I don't know how to explain it.
So I'm gonna stay on that topic. You had said earlier.
Yeah, because when it comes to change, you actually round up to the nearest one, so the 30 would actually be 31 cents.
Okay.
But I heard you say we're talking about change. We're talking about
Right.
money. So with money, we're used to
Oh,
seeing.
that one, which one that rounds to?
No. So it'd be like 28.
Mhm. You said it was 0.279, so that would go up to 0.28. So you've got those 2 numbers. Francis, you said earlier, what were we finding by doing this? You put some words with it. We're finding
The cost of it per ounce.
the cost per ounce. So for that first part, you've got 0.28. What does that mean?
is that the cost for each one?
The cost for each
Pounds.
ounce, and then the second one,
0.31. Well,
same thing, the
Mhm.
cost for each ounce. So that question, what's the best deal?
0.31.
I would buy the 13-ounce box, cause you're paying a little bit more, but you're getting
More.
more cereal and only paying a little bit more per ounce.
We all agree?
Oh yeah, it's 3 cents more.
In order to be the best deal, because you asked that question last week with the ice cream, remember? You're like, you guys think that's a good deal? What does it mean for something to be a good deal?
I say like you don't spend a lot of money on like a two little thing.
Which one were you spending less money?
So,
Okay.
A. So I see what you're. Are you willing to spend a little more money on something just to get
Yeah.
a little more?
I would, 'cause the 10-ounce box ain't gonna feed 6 kids.
well,
But 13. What if you were to buy 2 of those 10-ounce boxes? Would the amount you're paying change? Or I'm sorry, would the amount you're paying per ounce change?
Not really, no.
So if we want to get the best deal, meaning you're paying the smallest amount
Yeah.
per ounce, you've got all the math there. I think you're almost there. Which one is the best deal?
I feel like B. I don't know. I just think
Why is B the best deal?
it's 3 cents more. That's my opinion. You know.
Because you're getting 3 ounces more for 3 cents more. So if
Yeah.
you.
No, oh wait. Look at the prices. How much does that 10-ounce box cost?
279.
How much does that 13-ounce box cost?
399.
So you're not paying 3 cents more and getting 3 ounces more. Those prices are different there.
Oh well. Oh yeah, you got a point. I get A. I guess.
So,
If you're not thinking about feeding a family of 6, if you're simply thinking about which one is the best deal
I won't share my food.
in terms of the price per ounce, can we agree? A?
Yeah.
Why is A the best deal?
Because it's $4 and it's $2.79.
But use what you just found to compare.
It's like 0.31 and A is gonna be 0.28, right?
Mhm. So let's answer that last question. In order to get the best deal, which item will you buy?
A.
Yep. Write down A for us. Obviously, when it comes to grocery shopping, there's a little more that goes into it, right? Like maybe as like a household of 1, you don't need 13 ounces of cereal. Maybe as a house of 6, you do. But when it simply comes to the prices, I want to point out some stuff. And Carlos, you can sit down. Thank you. When it simply came to what you guys did here, in order to figure out what the best deal was, Francis, you got it right away. You said, let's compare the cost per 1 ounce. Right now, when we've got different amounts of cereal and different prices, it's harder to see which one's the better deal. But once you use division, and I love how you knew automatically, this is the cost per 1 ounce of cereal, then it's easier to compare. Being a better deal, Carlos, I think you were the one who said it, better deal means you're paying less for the thing. But we were comparing these numbers, not these. And we were using division to do it. What you were doing in this problem here is finding something called unit rate. What a unit rate is it's a special ratio. We were looking at ratios, what day was it? Last Thursday? It's a special ratio, but it's a ratio that compares the amount of something to 1 unit. So in that last problem, you were telling me the price for 1 ounce. So as an example, I could write price per ounce. I'm going to give another example. When you go to fill up your tank for gas, the signs always say,
Gallon for premium $2.77 right now, something like that.
you're giving me the exact cost, but it's the price per gallon that's posted. Can you think of some other examples of unit rate?
Like food. like at Speedway. I don't know. I was hungry that day. I didn't even care the prices. It was like what you get two for $5 or something.
Okay,
It was
so
actually like $2.50 each. I was like, you know what? I was hungry. I didn't even care.
all right. So what I heard you say is 2 for $5. That's actually the same numbers we had for that ice cream last
but,
time.
like the sandwiches are this small, and I didn't even complain. Like I didn't even care how much.
I'm gonna focus it back in on the math real quick. Is this a unit rate?
Oh, yes. Right.
What do we think? If I see a sign that says 2 for $5,
Because it's like part of the math. Like each one will be like $2.50.
but that's not what this says, though. I see what you're doing. Is this right here a unit rate? What did we say a unit rate is?
A unit of one.
Mm-hmm. Are we saying 2 for $1 or 1 for $5? There's no 1 in that ratio. But Carlos is so speedy with that math. He says he sees this and he immediately goes, "Oh, that's $2.50 for one." You're saying one sandwich?
Yeah.
Is that a unit rate?
Yes.
Yeah, because we've got that 1 in it. So I think just you're automatically seeing when you're trying to figure out something, if it's a good deal or if you're trying to compare two things, unit rate is really important. Your mind is just automatically calculating unit rate to figure out, like, what does that actually mean for me? These all are prices. I'm going to give one more that's not money. In the education world, especially if you have kids, something you hear a lot about is the number of students to teacher.
Oh, like going to a field trip type thing.
It could be for a field trip or just like class sizes. You know, if you want your kid to get like a lot of attention, you want to have a smaller student to teacher ratio. Here, right now, your ratio is 3 students to 1 teacher. Means I'm really able to focus all on you. I had a roommate when I first lived here who taught at a school where she had 50 students. So her ratio was 50 students to 1 teacher. I was not jealous of that. But those are, again, it's another example of a unit rate because you're comparing it how many students for 1 teacher. So another example that's not money. We were, just to go back to that last example, it's not cereal, but I did find this picture right here. When you're shopping, notice they do this for you. I don't know if you ever look closely at these, but it'll say the unit price. It's saying this can right here costs 7.3 cents per ounce. This can here costs 9.8 cents per ounce. So they'll do this on price tags, and that they do the math for you, that they're helping you compare. Again, like, forget about like what brand name or generic name these cans are. If you wanted the better deal, I see you're pointing over here, because it's less money per ounce. Cans might be bigger or smaller, but at the end of the day, if you're trying to compare just solely how much food I'm getting for the cost, you can use those unit prices there to compare. And I do that a lot when I grocery shop. Okay, so I've got, where are we at in the notes? We got this, and then we're gonna do this one together, and then I'm gonna have you try this one here. So for another example, we've got Carlos. I wish it was a skateboard, because you were talking about skateboards last week, but you're buying a motorcycle instead. I'm sorry. We've got Carlos wants to buy a new motorcycle. He wants to compare the gas efficiency for each motorcycle before he makes a purchase. The dealership presents the data below. So we've got the sports motorcycle, and then they give us a table. What do you notice with that table? It's that, I didn't hear you. The gallons of gas and the number of miles. So that first column, what does that mean? The 5 and the 287.5?
The number of miles and the 5 is like 5 gallons of gas.
Mm-hmm. So 5 gallons of gas means.
You can put it the motorcycle, right?
Yep. So he's gonna, if he puts in 5 gallons of gas in the motorcycle.
287.5. Is that a lot of money?
Oh, wait, that second number isn't money. What is the 287.5? Miles. So if he puts in 5 gallons of gas, finish that sentence. Yeah, it'll take him 287.5 miles. Again, 10 gallons of gas, is how much he needs to go 575 miles, 15 gallons of gas. He can go 862.5 miles and so on. So that's option number one, is you're gonna possibly get the sports motorcycle. The other option, leisure motorcycle, we've got a graph, and we haven't in this class yet seen a graph yet. What is that graph there telling us? What do you notice about it?
Just going up like a whole straight line.
Mm-hmm. Yep, so the line's going up, and you notice the straight line. What else do we notice in this graph?
And it has like the numbers are ready for you.
Mhm.
Like 2, 4, 5, like 6.
Yep, so we got
But
two,
it's,
4.
it's kind of like even numbers, like 2, 4, 6, 8, 10.
What are those numbers referring to?
Gas.
Gallons of gas, just like over here. And then we've got
Number of miles.
number of miles, also just like over here. I heard you say you saw some points. Let's look at the points. So we've got a point right here. What is this point here telling you?
The gas miles what's a gallon of gas?
So I heard it's telling you 2 gallons of gas.
And 110 miles.
107
Yep. So 2 gallons of gas will get you 110 miles. We could keep doing it with the graph too. This point here is telling you.
4 gallons.
Mhm.
20 miles.
Yep. It takes 4 gallons to go 220 miles, and we could keep reading this, but I think you guys got the point. The question's asking, which motorcycle is more gas efficient and by how much? To be gas efficient, what does that mean?
How many gallons per mile?
Gallons. Yeah. Well, how many gallons per mile? I'm going to flip that. How many miles you can go for 1 gallon.
Right.
If we want an efficient car, what does that mean about the miles per gallon? If your car's really efficient with its gas,
It tells you how many miles you can go on 1 gallon of
Mhm.
gas.
do we want to go a lot of miles on 1 gallon or not a lot of miles on 1 gallon?
A lot.
You're nodding and saying a lot, yeah. You want to get the most bang for your buck, right? So if you spend money on 1 gallon, you want to get as far as possible on that 1 gallon. So we're looking for the motorcycle that's going to get Carlos as far as possible. See, you're already trying to point at stuff.
The sports one getting more.
How do you know that?
You take 287.5, divide it by 5, it gives you 57.5 miles per gallon.
I'm going to have you pause right there. My hand is not obeying my brain. 200, you said 280, God darn. 0.5.
Divided by 5.
Okay, and that gave you
57.5 gallons per mile.
57 point,
5.
which one is it?
57.5 gallons per mile.
Gallons. Now look at what we're dividing here.
Mm-hmm.
We're dividing
Yep.
miles
In gallon.
by gallon. So it's miles
Per gallon.
per gallon.
And
I'm going to have you pause. We're going to share the joy of doing the math. Someone else tell me what else I need to do.
The same as the 10, so 575 divided by 10.
Yeah, let's do that. So you've divided this first one. What about the second one? If I do 575 divided by 10?
That will equal 570. Wait. 57.5.
What do you notice?
I prefer the 10 gallon.
it's still the same amount of
It's the same?
no matter how high you go.
Yeah.
No,
If I divide these?
Never mind. Never mind. I think 5 gallons.
If I divide these, what are we expecting to get?
The same.
The same thing. Is that what you're doing? If I divide these?
We get the same.
So what does that mean? I heard you kind of said it. It doesn't matter.
How many gallons you're still in the same amount?
Yeah, it's that same, put some math vocabulary with it. It's the same,
Very true.
it's the same ratio, or what are we learning today?
What's that? Wow.
Unit rate. It doesn't matter how many gallons or how many miles we go. It ends up being the same unit rate. It's the same miles per gallon because it's the same vehicle. So we figured out the unit rate for this one. Anything else your heart's just dying to do?
No. I'm trying to like figure it out. Which is the best deal.
So yeah, let's go back to the question. The question is, which one's the better deal? Which one's more gas efficient? We figured out the sports motorcycle needs 57.5 miles per, or sorry, the sports motorcycle is going to take you 57.5 miles per gallon. We're trying to compare. Is there something else we could do to help us compare?
110 divided by 2,
Where are those numbers coming from?
the laser motorcycle.
Yeah, this point right here, we've got 110 miles for 2 gallons. 110 miles divided by the 2 gallons.
Like it's
55.
55
Nine.
per gallon.
per gallon. We divided the miles by the number of gallons to get miles per gallon. Now you chose this point. Did we have to use that point?
No.
Use those
No.
ones.
You could use the other ones. If I wanted to use this one instead, what would I do for that point?
16, like so 880
Uh-huh.
divided by 16.
Yep. 880 miles divided by the 16 gallons. What's that one going to get you?
55 gallons.
Did you do that math or you just knew? It's going to be the same. So it doesn't, we've got a lot of data here. We don't need to use all the data to figure out that unit rate. You just need to use one for each motorcycle. So at this point we figured out sports motorcycle, 57.5 miles per gallon. Leisure motorcycle, 55 miles per gallon. I know you said you're just trying to figure out which one's the better deal, which one's more gas efficient. What would we say?
The sports.
Why the sports motorcycle?
You get more per gallon with that one than you do the leisure.
Yeah. Sports motorcycle. Cycle. Because, I'm going to write exactly what you said. Because you get,
Per gallon.
yep, more what?
Miles per gallon.
Yep. More miles per gallon. You could also tell me in that like explanation part, you could say because the sports motorcycle gets 57.5 miles per gallon, this one only gets 55 miles per gallon. We could figure out by how much. So you're telling me this one gets more miles per gallon? How much more?
By 2.5 miles per gallon.
How'd you get 2.5?
Take 57.5 and subtract it from 55
Yep. So subtract and it'll give us 2.5
miles per gallon.
more miles per gallon. It's just like in that interactivity when you were given the 2 robots. It's just like with the prices when you're given to the 2 prices. In order to compare these, we want to take it down to what that unit rate is. That's going to be the easiest way to compare the 2. For this one, is that the only way you could compare them? Could someone do this differently?
Like, or what you mean by that? Like,
Did we have to do this math in order to compare them?
well, you had to first. You need to figure out which is the number, the miles per gallon, right?
Mm-hmm. So to answer that question by how much, we needed to know the miles per gallon to answer that. If I just simply asked you, like, which one's the better deal? There's a way to do this without finding the miles per gallon, and I wanted to talk about it. Remember, each of these is giving you a lot of data. Is there any data they were giving you in common?
But if it,
So earlier you noticed this is counting up by 2.
yeah, but
So I
then
know
when it says number of gallons, it's counted by 5, 10,
Mhm.
15, 20.
So is there a point where they have something in common? You're noticing this one's counting up 2, 4, 6, 8, 10, 12.
I don't know what's the
This one's
specific-
counting up 5, 10, 15.
I forgot like the specific word for it.
You don't need a specific word. Is there a number they both have in common?
The only common number is just like the miles per gallon, 57.5 on the 9.
Yeah, they have 10 and 20 in common. So let's focus in on the 10. This one here is telling us it takes 10 gallons to go 575 miles. This one here is telling us 10 gallons, 550. I'm going to write that down. 10 gallons, you can go 550 miles. How could we use that information to help us figure out what's the better deal?
575 subtract by 550.
So that means if you put in 10 gallons, I heard you say subtract, this one would be how much further?
25 miles.
Yeah. At the end of the day, you just need an amount that they have in common. I can't compare 10 gallons with 2 gallons, but I can compare 10 gallons with 10 gallons, just like I can compare 1 gallon with 1 gallon. You just need them to have something in common in order to compare. For this question, because I'm asking you by how much, we needed to find those unit rates. And lots of times in these questions, I'm going to ask you specifically, what is the unit rate? But even if there wasn't someone in this room thinking this, there's usually someone who's looking at this and going like, oh, 10. I don't have to do any math. I can just compare those. And I do want to say that's a valid way to do this too. But if I'm asking about the unit rate, what is the unit rates? The 57.5 miles per 1 gallon and the 55 miles per 1 gallon. Unit rate's always the one. How are we feeling about this question? In a good way. Okay. I'm going to erase all this. There's one below for you to try. You guys did great with this graph, by the way. I know we hadn't seen a graph like that yet. Yeah. You're trying this one about Mr. Steiner. For this here, so you've got the 20 divided by 1249. What does 20 represent? 20 batteries divided by
dollars.
So you're finding when you're dividing the batteries by the dollars, you're finding the number of batteries per dollar.
Oh, okay.
So we're figuring out here it's $1.60. Sorry, it's 1.6 batteries per dollar. And when you go to buy something, it's the other way around. You want to figure out the cost per battery, not the battery per dollar.
Okay.
So if we want it the other way around, what do I need to do?
This is it.
You want the cost per battery, right?
Yeah, I'm trying to figure it out. But
Read that division like per or for each. So this is figuring out
20.
the batteries
Per.
per cost. We want cost per battery, so
Mhm.
you've got to flip that around.
So I need to put 12.49 divided by 20.
Mm-hmm. Yep, and then same thing here. You want the cost
Oh,
first.
okay.
Cost divided by battery is going to give you cost per battery.
Okay.
Mm-hmm. Let me peek at what you got. Can I see you type that second one in? That number was eight. The divide by 20 is good. Mm-hmm. There you go. Mm-hmm. Tell me where that first one came from, the 0.36.
7.20 divided by 20.
It's telling us the $7.20 is for what?
For a pack.
For a pack of how many?
20 AA batteries.
Will you read that whole sentence again to me? Start right here.
The nearby store sells a 20 pack of AA batteries for $12.49 and a 12 pack of.
Tell me what you just realized.
I didn't say this. I was
Uh-huh.
on a 12 pack for this battery.
Yeah. You got the right idea, but that we're gonna change that because it's not for 20 batteries. It's for.
So,
Yeah. Ooh, I love all the writing.
that's what I think.
Tell me why.
Because the 12 pack is sometimes 20 in the range 0.60. In the 20 pack, I'm getting 6 more batteries. They're gonna be 0.62. I'll be paying $12.49. I'm paying like $5 or something more, right?
Mm-hmm. Okay. Let's go back to what the question's saying. It's saying he wants to buy how many batteries?
60.
Could he get 60 batteries by buying 12 packs?
No, you need to buy like 3 of them, right?
So let's do the math. So 12 and 12.
That's gonna be 24.
Mm-hmm. Another 12.
That's gonna be 36.
Mm-hmm. Another 12.
48.
Uh-huh. You're almost there. Another 12.
Yeah, that's a lot.
It's
60.
specific. It's 60. Mm-hmm. Could he get to that 60 by buying the 20 packs?
Oh yeah.
Yeah. You did the harder one, 20, 40, 60. So it doesn't matter which one he's buying. He can buy either one to get to the 60 batteries. He's going to have to buy multiple of either one regardless. Which one's going to be the better deal for him to buy multiple of?
20 pack.
You figured out the 20 pack was?
That's the rate 0.62.
Mm-hmm. You figured out the 12 pack was?
60.
Mm-hmm. So which one's going to be the better deal?
20 pack.
Why? We're gonna talk about it in a second. All right. I want to talk through it. You guys started figuring out the math for this first part. Tell me what some of the math you were doing.
1249 divided by 20.
Mm-hmm. Could we do divided by, wait, I'm sorry, 1249 divided by 20? Good. So you did the cost divided by the batteries. Can we divide it the other way around?
No.
It's going to tell you something different. This right here is telling you the cost per battery. In this situation, that's what we want to know. The second question even asks about the cost of one battery. We need to divide the cost by the batteries to get the cost per battery. It's got to be in that order. So when you guys did that, you figured out,
60 cents
and you're already telling me it's money. So 60 cents. Tell me more.
per battery.
Yep. So in that pack, picture a pack of 20 batteries. Each one of those batteries in that pack costs 60 cents. That's how you're getting to that total. What other math did you guys end up doing?
720 divided by 12.
And that gives you,
The top one gives you 62 cents.
I was wondering.
And the other one
Thank
gives
you.
60 cents per battery.
There you go. Okay. And you're saying per battery.
Yep.
So again, picture a pack this time of 12 batteries. In that pack, each battery in that pack costs 60 cents. We are trying to figure out which one is the better bargain. We've got Mr. Steiner, and they told us he needs to purchase 60 batteries. So either way, he's going to have to purchase multiple packs. There's no pack that's selling 60 batteries. Which one is a better bargain? Which one's a better deal?
$7.20.
Why is that?
Because if you take $7.20 and you divide that by 5, it's still 60 batteries. If you take $2.49 divided by 3, it's 60 batteries, but the one for $7.20 is cheaper, 2 cents cheaper.
There's a lot to unpack there. So one thing I heard is 2 cents cheaper. You're already jumping down to the second part here. What is the difference between the costs of batteries?
2 cents.
We all can agree that the batteries in the 12 pack, so I'm going to say 12 pack batteries are 2 cents cheaper. So that's one thing I heard you say. I heard some other numbers in that. So let's get back to that.
If you take $12.49 and divide that by 3,
Divide by 3?
Multiply by 3, you're going to get 60.
Now where is 3 coming from?
Because 3 packs would give you 3 packs of 20 would give you 60 batteries.
Okay. So she's figured out up here, this is the cost for a 20 pack. In order to get 60, we would need to buy 3 of those packs. Now I do want to pause here. Simply by knowing this, you know enough information to know this one here is the better deal. It's the better deal because each battery in those packs would be 2 cents cheaper. But you're going a step further and saying like, well, let's figure out what the total cost for each of them would be. If he's buying the 20 packs, this would be the cost for him to get to 60. Did you figure out what that equals?
$37.47.
47 cents, okay. And then for the 12 packs,
You would have to multiply that by 5.
you need 5 12 packs to get to 60 batteries.
And that would be $36.
$36 even. So if looking at those prices, what do we see?
The $12 thing is gonna.
The 12 pack.
Yeah,
Mhm.
12 pack is gonna be, what is it? Oh, okay, $36.
Mhm.
Yeah, and the other one, if you get like 3, is gonna be $37.
Yep.
47 cents.
What do you have?
Question.
You have a question? Go for it.
How do you multiply by 3 and 5?
Tell us one more time. Where did that 3 and 5 come? The 3 came from,
Because it would take 3 packs to equal 60,
Yeah.
this is a 20 battery pack.
and the 12 pack would take 5 packs to equal 60.
So 3 times 20 batteries gets you to the 60 goal. 5 times 12 batteries gets you to the 60 goal. So both of you are getting you to 60 batteries. This is another way you can compare though. If you're comparing the unit rate, the cost of one battery, you can see that this is a better deal. I know it's 2 cents cheaper, but that does not mean 60 batteries would be 2 cents cheaper. Every single battery you're buying is going to be 2 cents cheaper. So for a total of 60 batteries, Francis has gone and done the math for us, and we can see just how much of a better deal it is. It's similar to what we were doing with the cereal and the ounces. You were like, oh, but like, you know, it's only a couple cents cheaper, and this one's only a couple cents more, so this one might be the better deal. Know that this is just the cost of one battery, and so if you're buying a ton of batteries, that's going to make a bigger difference over time. This is true. Sometimes with brands, it's the same brands, and just if you're getting more, they make it a better deal because they want you to buy more. We're going to move on to one last example. It's a little different because we're no longer going to talk about money. We're going to talk about speed. When you measure speed, there are multiple ways you can talk about speed. Here, the most common one I think of is when I get in my car and I'm driving a certain speed. How am I measuring my speed? Yeah, miles per hour. Is that the only way you can measure speed? Yeah, the United States does miles per hour. Not every country does miles per hour. A lot of other countries do kilometers per hour. I think most of Europe does kilometers per hour, and a lot of other countries. We're special. Is it always per hour?
It's like the highway, right? It's like you're going to 70 per hour.
So when you're talking about driving in cars, it's usually hour. Speed in general, though, maybe not in a car. Do you think speed is always per hour? You're shaking your head no. Can you think of another example where it's not per hour?
Because in my car, it shows like MP, right? Sometimes it was like, what's MP stand for? I don't know.
Miles per hour, mph. But outside your car, can you think of one? You said no.
Oh, I know. People from Atlantic, what's it called? The running track?
Mm-hmm.
What's it called?
Do you remember how they measure their speed?
I forgot what it's called.
That's the one I was going to say. When in like the Olympics, the track runners, they usually measure it in meters. So I'm going to use M for meters. Meters per second. It's going to depend on what you're talking about, right? If I'm talking about like a human, meters per second might be reasonable. If I'm measuring the speed of like a snail is not going meters in a second. You might want to say like inches per second or inches per hour, honestly. But it might change depend on what you're talking about. I've got 3 examples down here. Do you see what all 3 of these have in common?
Hour.
No, because we got seconds here. They all have per in common. What do all these first ones have in common?
Meters, whatever.
Miles, kilometers, meters. What are all of those?
Distance.
Ooh, yeah. So we've got distance. And I already heard it. And then this last one is time. Those other examples I got when I was pretending I'm measuring the speed of a snail, I think I said inches per, what did I say? Maybe inches per hour. I feel like if you're measuring a snail, it's probably gone like 2 inches in an hour. But that's another example, right? A distance and a time. Maybe it should be like inches per day. I don't know if we're talking about a snail. But anytime you're talking about speed, it's always in this format. You calculate speed by finding the distance over time. So when we say in our car that we're going 60 miles per hour, what does that mean? It means if you're driving 60 miles per hour, you have gone 60 miles in 1 hour. This is going to be important for this last part on finding speed. So I've got this little one here says, Chris Johnson ran the 40-yard dash in 4.24 seconds. So it's more of the track running you were talking about. 40-yard dash in 4.24 seconds. What is the rate of speed? And then we're gonna round our answer. In order to calculate his speed, what am I gonna wanna do? I'm gonna round my answer.
40 divided by 4.24.
Yeah. We just said earlier you calculate speed by finding the distance. Instead of per, I'm going to say the distance over. I'm doing this with my hand. What math is that?
Divide.
Yeah. Distance over time. So that's exactly what you said. You didn't sound confident, but you had it. We're going to take the 40 yards. Yards is abbreviated YD, by the way. 40 yards divided by our 4.24 seconds. Now again, I've given you a calculator because we're not going to get hung up on doing that math by hand. Do we all agree?
Yeah, but it says you're gonna round it up to the nearest tenths.
Nearest
Hundreds.
hundredth. Do we know what hundredths are?
Well, for like the 100,000s is 2 is tens, 4 is hundreds.
Yes. So it's talking about a place the decimal is in after that decimal point. I heard you say this is tenths. The second one is hundredths.
And the last one is thousands.
Yep. Well, it's not the last one. I could keep going, but tenths, hundreds, thousands, 10,000s. What we needed to know is that this right here means there's going to be 2 digits after. Decimal. Okay. So I heard a number, but I didn't write it down. What did you get when you divided?
9.40.
9.40?
Yeah, so it's be on 9.43,
But using what we said earlier, it would round to
100.
40. What does that number there mean?
The rate of speed.
It is the rate of speed. Put some words with it. 9.40 what?
Yards per second.
Yeah. Go back up to the math we did. Yards per second. It means he has gone 9.40 yards in 1 second. Think about that. That's like really insane. A yard is 3 feet. So 1 yard is 3 feet. 9 yards. What? How many feet is that? Yeah. 1 yard is 3 feet. So 9 yards. I feel like I heard you whisper it.
27?
Yeah, 27 feet. He's going over 27 feet in 1 second. I cannot picture my body doing that, but that's why I'm not a track runner. But we're figuring out his speed. We're figuring out he's going 9.40 yards per second. We got one last one, and then I'm going to have you try the last one on that paper. The second one says, who walks at a faster rate? Someone who walks 60 feet in 10 seconds or someone who walks 42 feet in 6 seconds?
6 divided by 10, that's gonna equal 6.
I'm going to just write down what I heard you say. 60 divided by 10 gives us 6.
Yeah,
What did we just figure out there?
the seconds, wait,
Feet per second.
Go back to what you did. You did 60 feet
yeah.
divided by 10 seconds. So we're figuring out here 6
Feet of second.
feet per
Per
second. Feet per second.
42 divided by 6, 7.
hmm So you 7.
Per second.
Yep, feet per second. So the question, who walks at a faster rate?
42.
Yep, person number 2. You know, I love asking you why. How could you justify for that to me?
Because you walk
1 more feet.
more than half of it feet.
No, it's 1 foot. He walks 1 foot.
1 feet because of
There you go, 1 feet per second faster. So we would say our second walker walks at a faster rate because he walks 1 foot per second faster than the other person. You could also just say because he walks 7 feet per second, first guy walks 6 feet per second, 7 feet per second is faster. Or you could go ahead and do that math. Notice again, it's the distance divided by time. It's always going to be in that order. How are we feeling about speed? Good? All right. There is one last one at the bottom for you to try. You guys did great today. This one here is the last one you're doing. Goodbye, people at home.